Hello, and welcome to the Science for Sleep. I'm truly glad you've wandered your way here. Maybe today felt long and heavy, or maybe you're someone who prefers drifting off to deep thoughts and cosmic wonders instead of counting sheep. Either way, tonight's journey is made just for you. There's nothing you need to do now except rest. Allow your thoughts to soften, your breathing to slow, and your body to feel lighter, as though gravity itself has grown gentle. Because tonight, we're not only gazing at the stars, we're floating through our home galaxy, the Milky Way, a vast spiral of stars, dust, and dark matter that has been quietly turning through space for more than 13 billion years. Yet beneath its beauty lie mysteries, wandering stars, unseen forces, and ancient remnants that challenge what we once believed. We'll drift from its sweeping spiral arms into its hidden, secretive core, from immense collisions to stars older than the galaxy itself. You'll hear of black holes and stellar nursery, and the strange, unfinished tale of a galaxy that is still growing. Some of what you discover tonight may gently surprise you, or at least spark a quiet curiosity as you slip into sleep. And before we begin, if these calm explorations help you unwind or offer a gentle ending to your day, consider liking and subscribing to the channel. It helps others find their way here as well, one sleepy soul at a time. Now, let's begin. The Milky Way has already collided with other galaxies, and it will again. Our galaxy may feel like a peaceful home, yet it is built from the remnants of others. Over billions of years, the Milky Way has drawn in smaller galaxies, pulling them apart and scattering their stars into long tidal streams that wrap around the disk. One of these, the Sagittarius dwarf galaxy, is currently being torn apart. And far out in the night sky, Andromeda is slowly drifting closer. In about 4.5 billion years, these two great spirals will merge in a vast cosmic encounter. The stars themselves will almost never collide, but the shapes of both galaxies will change forever, folding into a new, quiet form. Even galaxies are not eternal. They grow, collide, and begin again. Some stars in the Milky Way are older than the Milky Way itself. Not every star in our galaxy was born here. Certain halo stars, ancient, metal-poor, and wandering along long, tilted paths, appear to have formed before the Milky Way fully took shape. Astronomers believe these stars originally belonged to small primordial galaxies that merged with ours billions of years ago. Their chemical makeup holds almost no heavy elements, suggesting they were born shortly after the Big Bang. They drift high above the galactic plane, like elder spirits from a time before spirals, before order. In their faint light, we glimpse a universe that was younger, wilder, and still learning how to become what it is today. Our solar system races around the center of the Milky Way at over 828,000 kilometers per hour, more than 230 kilometers every second. And still, it takes about 225 million years to complete just one full orbit. This long journey is called a galactic year. In Earth time, we've only completed about 20 of these galactic laps since the solar system was born. When the first dinosaurs walked the Earth, we were in a completely different region of the galaxy. The stars we see above us now were not always nearby, and they will not always remain. Everything is moving, quietly, slowly, endlessly. Even as we sleep, the Earth turns, the moon circles, and the entire solar system drifts onward through a galaxy in motion. The galaxy is still growing. Though the Milky Way is ancient, it is not finished. Even now, it continues to gather material, gas from the space between galaxies, stars stolen from captured dwarf systems, and vast streams of dark matter that feed its halo. its growth is not like that of a living creature, but like a deepening gravitational structure unfolding over time. Some of this happens quietly through the slow inflow of clouds. Other times, it arrives with disruption, as satellite galaxies are torn apart and their stars scattered across the sky. The galaxy we live in today is not the same one the dinosaurs once saw. And the one your distant descendants may know could be larger still. Stitched together from the ruins of countless smaller worlds, we don't actually know how many arms the Milky Way has. It seems like something we should easily know. How many spiral arms extend from the center of our own galaxy? But from our position deep within the disk, seeing the full structure is incredibly difficult. Thick dust clouds obscure distant regions. Stars blur together into glowing layers. For decades, astronomers believed the Milky Way had 4 main spiral arms. More recent observations suggest there may be fewer, or that the arms twist, split, and fade in complex ways we don't yet fully understand. Some dissolve into fragments. Others wrap around in unexpected paths. The Milky Way may not be a neat pinwheel at all, but a living, layered swirl shaped by forces still partly unknown. Most stars drift calmly through the galaxy, but a rare few are violently flung outward at tremendous speeds, so fast they can escape the Milky Way entirely. These are known as hypervelocity stars. Some are the surviving remnants of binary systems torn apart by the supermassive black hole at the galaxy's center. One star falls inward and disappears. The other is hurled away like a cosmic slingshot, racing into darkness at over 1,000,000 kilometers per hour. These rogue stars travel alone, far from the galactic plane, like glowing comets with no path back home. They remind us that even in a galaxy ruled by gravity, there are moments of sudden release, quiet expulsions that send stars vanishing into the intergalactic night. The Milky Way and Andromeda are on a slow collision course. High above the horizon, the Andromeda galaxy appears as a faint smudge to the naked eye, a spiral much like our own, lying over 2 million light-years away. And yet, it is steadily moving closer. In roughly 4.5 billion years, the Milky Way and Andromeda will meet. It will not be a violent crash in the way we often imagine. Stars are far too distant from one another to collide directly. But gravity will stretch both galaxies into long, sweeping arcs. Tidal tails will unfurl. Black holes may spiral toward one another. And after billions of years, the two will settle into a single, larger galaxy. A slow, graceful dance. The future of our home, written quietly among the stars. Most stars in the Milky Way orbit the center in the same general direction, but not all follow this rule. Some, especially in the distant halo, move in the opposite direction, traveling in retrograde motion. These stars likely came from elsewhere, born inside dwarf galaxies that were later absorbed. Their reversed paths are a subtle signature of their foreign origins. It's as though the galaxy carries old memories within its motion. Stories of ancient mergers and distant encounters preserved not in light, but in the slow, patient turning of stars against the flow. The Milky Way may have consumed dozens of dwarf galaxies. Over billions of years, it has not grown in isolation. It has grown by taking in others. Small companion galaxies drifted too close, were captured by gravity, and slowly pulled apart. Their stars now belong to our halo, our disk, or stretched into vast stellar streams. Astronomers have traced several of these long-lost mergers by studying stellar motion and composition. One especially massive event, known as the Gaia-Enceladus merger, added countless stars and reshaped the early structure of our galaxy. The Milky Way is not a pristine spiral. It is a mosaic of quiet collisions, stitched together from the remains of many smaller worlds. Every star carries a chemical fingerprint, a unique pattern of elements imprinted at birth. By studying these signatures, astronomers can trace a star's origin and history. Some stars are rich in heavy elements like iron and calcium, suggesting they formed in dense, evolved regions. Others are nearly pure hydrogen and helium, born when the universe was still very young. These chemical differences allow scientists to group stars into families, uncover ancient mergers, and rebuild the hidden story of how the Milky Way formed. In this way, chemistry becomes a kind of time machine, allowing us to read a star's past like a line of ancient poetry written in light. Across the sky, faint ribbons of stars stretch in long arcs and gentle curves. These are stellar streams, the remains of smaller galaxies that wandered too close to the Milky Way and were pulled apart by tidal forces. As their stars continue to orbit, they smear into delicate trails, tracing ancient paths through space. Some loop around the galaxy like ghostly rings. Others plunge inward toward the core. These streams are living evidence of past collisions, quiet mergers that slowly built the Milky Way over billions of years. Like the rings in a tree, the galaxy carries the record of its past in every thread of light. Our galaxy is not perfectly flat. The Milky Way's disk bends upward on one side and dips downward on the other, forming a slow, graceful wave across the stars. This subtle warp remained hidden until radio telescopes mapped the vast clouds of hydrogen extending far beyond the visible starlight. Astronomers believe this bending may be caused by satellite galaxies tugging at the edges or by clumps of dark matter shaping the structure from below. Like ripples in a giant spinning sheet, the warp reminds us that even galaxies are never fully still. They bend, shift, and slowly change form under unseen forces. From far away, the Milky Way might appear to be dancing through space. With the naked eye, you can only see about 0.03% of the Milky Way. Under a truly dark sky, far from city lights, you might spot a few thousand stars. It feels like an ocean of light, but it is only a drop. The Milky Way contains over 100 billion stars. Most are hidden behind thick veils of dust, or are simply too faint or distant for human vision. The pale, glowing band that stretches across the sky on moonless nights is just the faintest whisper of the true galaxy surrounding us. We live immersed in a colossal river of starlight, yet almost all of it remains invisible to us from within. Stars do not orbit the galaxy like planets orbit a sun. Their motions are freer and more varied. Some race quickly through the inner regions, while others drift slowly along the outskirts. This difference in speed is what creates spiral arms. The arms are not solid structures, but patterns, like slow-moving traffic jams of stars and gas drifting through space. As these density waves pass, they trigger new stars to form, lighting up the arms in brilliant blues and whites. Our own sun is part of this great swirl, moving in and out of these patterns across deep time. The galaxy is not a clock. It is a current, and we are drifting within it. By all logical measures, the Milky Way should not hold together. Based on what we can observe, stars, gas, and dust, the outer regions of the galaxy are spinning too fast. They should be thrown into space like leaves in a storm, and yet they remain bound. The answer lies in dark matter. This mysterious substance does not shine, reflect, or emit light, yet it exerts gravity. And there is so much of it that it outweighs all visible matter in the galaxy many times over. We still do not know what dark matter truly is, but without it, the Milky Way would fly apart. It is the invisible framework that holds everything in place. At the very heart of the Milky Way rests a supermassive black hole known as Sagittarius A. It is more than 4 million times the mass of the Sun, yet contained within a region smaller than Mercury's orbit. We cannot see it directly, but we have watched nearby stars whip around it at staggering speeds, tracing invisible loops through space. Sometimes, gas and dust slip inward and flare brightly in X-rays as they spiral toward the event horizon. For now, Sagittarius A lies mostly quiet, but long ago, it may have blazed like a quasar, lighting up the galaxy from within. It is the silent conductor of the Milky Way's core, guiding a slow, relentless dance of stars. The central bulge of the Milky Way is shaped like a cosmic peanut. When astronomers carefully mapped the galaxy's center, they uncovered something unexpected. The bulge is not a smooth, rounded ball of stars, but a three-dimensional peanut-like structure. When viewed from the side, it swells in the middle and narrows at the ends, like a twisting hourglass made of starlight. This unusual shape likely formed from the galaxy's central bar, a dense band of stars that rotate slowly, buckling and rising over time. These inner structures are sculpted by gravity, billions of years of motion, and the accumulated rhythm of countless stellar orbits. We live in a spiral galaxy, yet its heart is layered, intricate, and alive. The spiral arms of the Milky Way are shaped by stellar nurseries. These arms are not made only of stars, but of the places where stars are born. Vast clouds of hydrogen, dust, and molecules drift through the galaxy. When these clouds pass through spiral arms, they are compressed and ignite with newborn suns. These glowing regions are called stellar nurseries, chaotic, luminous, and full of movement. Ultraviolet light from young stars illuminates the surrounding clouds, painting the arms with radiant blues and silvers. These bursts of creation trace the spiral pattern, outlining the galaxy's curves with quiet fire. Every star, even our sun, was born in one of these cloudy cradles long ago. The Milky Way is wrapped in a vast, dim halo. Beyond the bright spiral disk lies a faint, spherical region that envelops the entire galaxy. It contains ancient stars, globular clusters, and enormous amounts of dark matter. Though nearly invisible, this halo may hold most of the Milky Way's total mass. Its stars are scattered across immense distances, moving along slow, sweeping orbits that rarely touch the disk. The halo also preserves the fossil remains of ancient galactic mergers, streams and shells of stars left behind as cosmic echoes. It is the galaxy's outer memory, quiet and dim, yet still moving, still shaping what the Milky Way will become. The Milky Way is home to more than 150 globular clusters. These are among the oldest objects in the galaxy, dense, spherical collections made of hundreds of thousands of tightly bound stars. They orbit the galactic center through the halo like moths circling a distant flame. These clusters are remarkably stable, some more than 12 billion years old, and many contain. These ancient clusters contain stars that existed even before the Milky Way itself took shape. Their stars are metal poor, meaning they formed before the universe had time to create many of the heavier elements. They act as living time capsules, preserving clues about how the galaxy formed, what it absorbed, and what the early cosmos was like. These quiet golden spheres drift patiently above and below the galactic plane, glowing softly in the dark. The galaxy is still growing. Though the Milky Way is incredibly old, its story is not finished. Even now, it continues to draw in material. gas from the space between galaxies, stars captured from dwarf systems, and flowing streams of dark matter that feed its vast halo. It grows not like a living creature, but like a gravitational structure deepening over time. Some of this growth occurs quietly through slow-moving clouds drifting inward. At other times, it arrives with upheaval, as satellite galaxies are torn apart and their stars scattered across the heavens. The galaxy you inhabit today is not the same one the dinosaurs once saw. And the one your distant descendants may know could be larger still, stitched together from the remains of countless smaller worlds. Rogue stars are hurled from the core. Most stars drift calmly through the galaxy, but a rare few are thrown outward at staggering speeds, fast enough to escape the Milky Way entirely. These are known as hypervelocity stars. Some are the surviving remnants of binary systems shattered by the supermassive black hole at the galaxy's center. One star falls inward and disappears. The other is flung outward like a cosmic slingshot, launched into the darkness at more than 1,000,000 kilometers per hour. These wandering stars travel alone, far from the galactic plane, like luminous comets with no path home. They remind us that even in a galaxy ruled by gravity, there are moments of sudden release, quiet expulsions that send stars racing into the intergalactic night. Star formation is slowing down. Long ago, the Milky Way was far more active, bursting with new stars born from dense, collapsing clouds. But in more recent eras, the pace has eased. There is still gas available, but much of it is spread thin, heated, or locked in forms that resist collapse. The galaxy has not stopped making stars, but it is settling into a calmer rhythm. Astronomers believe that star formation peaked billions of years ago and has been gradually declining ever since. This does not mean the end is near, only that we live in a quieter chapter. A mature spiral glowing gently in its middle age, still creating stars, but no longer in a rush. Some stars formed before the Milky Way even had a disk. The broad, flat spiral structure we now recognize as the Milky Way developed slowly over time. Yet some of the stars within it are older than the disk itself. These ancient stars dwell mainly in the halo and the thick disk, and they formed when the galaxy was still assembling. A loose cloud of stars, gas, and dark matter slowly pulling inward. By studying their chemistry and motion, astronomers can look back into the era before structure, before spirals. These stars are the elders of the galaxy, silent witnesses to its birth and the long, gradual shaping of what we now call home. One galactic year lasts about 225 to 250 million Earth years. As the Sun orbits the center of the Milky Way, it completes one full revolution every few hundred million years. This immense cycle is known as a galactic year. In the time it takes the Sun to complete a single orbit, continents drift, species rise and vanish, and entire geological ages unfold. It is believed that we are currently about halfway through one such orbit. The last time our solar system passed through this region of its path, the supercontinent Pangaea had only just begun to fracture, and dinosaurs had not yet appeared. A galactic year is the slow heartbeat of cosmic time. The Sun has completed fewer than 25 galactic orbits. In its roughly 4.6 billion years of existence, our Sun has circled the Milky Way only around 20 times. That is fewer than one might expect, considering its incredible speed, nearly 800 to 30,000 kilometers per hour. But the galaxy is so vast and the Sun's path so long that each orbit takes hundreds of millions of years to complete. We often think of the stars as ancient and unmoving, yet our solar system is still young on a galactic scale. a newcomer in a city of far older, well-traveled suns. We are carried along in the galaxy's motion, but still early in its long and winding story. The Milky Way's rotation defies Newton's expectations. According to classical physics, stars farther from the galactic center should orbit more slowly, just as distant planets move more gently around the sun. But in the Milky Way, stars in the outer regions move almost as quickly as those near the center. This contradicts what Newton's laws alone would predict. Astronomers believe the reason lies in dark matter, an invisible, unknown form of mass that surrounds the galaxy in a vast halo. Without dark matter, the galaxy would not remain intact. With it, the equations finally make sense. The Milky Way turns like a solid wheel, not because we fully understand it, but because something unseen is holding it together. The galaxy contains enormous molecular clouds. Scattered throughout the Milky Way are massive, shadowy clouds of cold gas, the raw material from which stars are born. These molecular clouds, made mostly of hydrogen molecules mixed with dust, can stretch for hundreds of light years. Deep within their cold, dense interiors, gravity gathers matter into clumps that collapse into new stars and planetary systems. Some of these clouds are so thick and cold that they absorb visible light entirely, appearing as dark voids against the star-filled sky. They are the galaxy's hidden wombs, quiet, secret places where the future begins in silence, wrapped in curtains of shadow and gas. Supernovae stir the galaxy like great storms. When massive stars reach the end of their lives, they explode as supernovae. Events so powerful they can briefly outshine entire galaxies. These explosions do not only bring destruction, they also create. Shock waves surge through the interstellar medium, compressing nearby gas clouds and igniting new waves of star formation. They enrich space with heavy elements like iron and gold, forged in the heart of the dying star. In this way, supernovae act as storms within the galactic ecosystem, stirring, fertilizing, and reshaping everything around them. They are moments of chaos that are destructive, radiant, and necessary. Dust hides vast regions of star formation. The Milky Way is filled with light we cannot see. Interstellar dust, tiny grains of carbon, silicates, and ice, threads through the galaxy in clouds and drifting veils. Invisible light, it obscures enormous regions of space, blocking stars and entire nebulae from view. Yet behind this veil, star birth continues. Infrared telescopes can peer through the dust, revealing sparkling nurseries filled with newborn suns. What appears as darkness is often a cradle. The dust, though it hides, plays a vital role, absorbing heat, allowing gas to cool, and shielding the delicate earliest stages of stellar birth. What seems like emptiness is often the beginning of something luminous. There are starless gas clouds drifting through the galaxy. Not every cloud of gas becomes a star. Across the Milky Way, astronomers have found vast, cold clouds that seem ready for collapse, yet remain dark and dormant. Some are too thin. Others may be stabilized by magnetic forces or internal turbulence. These starless clouds wander through the galaxy like silent possibilities, rich in molecular hydrogen, but untouched by fusion. They may one day ignite, or they may drift until torn apart by outside forces, their gas recycled into other regions. In these clouds, the galaxy seems to hold its breath, waiting for the right disturbance to spark something new. The Milky Way constantly recycles matter across generations. Stars are not permanent. They are born, they burn, and they die. And in death, they return their material to the galaxy. Supernovae scatter heavy elements. Red giants shed their outer layers. Planetary nebulae drift outward into space. This enriched matter joins the interstellar medium, where it cools, condenses, and eventually forms new stars, planets, and even life. Every atom in your body has passed through this cycle, born inside a star, scattered into space, and gathered into new form. The Milky Way is not a static stage, but a vast engine of renewal. It breathes with its stars, creating, dissolving, and beginning again. Metal-poor stars preserve clues to the early universe. In astronomy, metals refers to all elements heavier than helium. The earliest stars formed when almost none of these elements existed, because earlier generations of stars had not yet forged and spread them. Today, astronomers search for metal-poor stars in the Milky Way's halo. These faint, ancient stars preserve the chemical conditions of a vanished era. By studying their composition, we peer into the primordial universe, into the time shortly after the Big Bang, before galaxies matured and before the Milky Way itself fully formed. They are fossils made of light. Some stars wander far from their place of birth. A star's origin does not always determine its fate. Over time, many stars drift away from the clouds that gave them life. Nudged by gravitational encounters, orbital resonances, or the slow pull of spiral arms. Some stars are ejected at high speeds, flung across the disk or into the halo. Others migrate gradually, shifting inward or outward as they spiral through the galaxy. Even our own sun is no longer where it began. Tracing these stellar paths reveals a Milky Way that is anything but still, a galaxy alive with motion, exchange, and quiet displacement. For a star, home may only ever be temporary. The galaxy's habitable zone may stretch across tens of thousands of light years. Just as Earth lies within a Goldilocks zone around the sun, not too hot, not too cold, the Milky Way may possess its own galactic habitable zone. This region likely resides between the dangerous inner core, filled with radiation and gravitational turmoil, and the outer edges, where metals are sparse and planets may struggle to form. Between these extremes lies a wide, stable band, where star density is moderate and elements like carbon, oxygen, and iron are plentiful. Earth rests within this zone, one quiet orbit in a vast cosmic swirl where life may not be alone in finding a foothold. The spiral arms are not fixed structures. The Milky Way's sweeping arms may appear permanent, like glowing pathways carved into space, but they are not made of the same stars forever. Instead, they are patterns, slow-moving density waves that ripple through the disk. As they pass, they compress gas and trigger new star formation. Stars drift into these arms, shine for a time, and then drift back out again. The spiral pattern moves at a different speed than the stars themselves, like a traffic jam sliding down a highway. From a distance, it looks like order and form. From within, it is a shifting flow of motion shaped by gravity and time. Never fixed, always moving. The Milky Way hums with invisible radiation. Beyond what our eyes can see, the galaxy shines with mysterious forms of energy. Cosmic rays, high-energy particles born in supernovae and distant galaxies, stream through space and pass through your body every second. X-rays and gamma rays shimmer from collapsing stars and black holes. Radio waves drift from cold gas clouds, pulsars, and the thin breath of hydrogen. These unseen signals reveal what visible light cannot. The violence, magnetism, and ancient fires still flickering within the galaxy's bones. When you look into the night sky, you see only a narrow slice of the Milky Way's true spectrum. Beneath the stars, the galaxy hums softly in countless hidden frequencies. A secret symphony in the dark. Enormous gamma-ray bubbles rise above and below the galactic core. Stretching tens of thousands of light years above and beneath the center of the Milky Way are two vast, ghostly lobes of high-energy light known as the Fermi bubbles. Discovered only recently, they glow in gamma rays like twin balloons emerging from the galaxy's heart. Their exact origin remains uncertain. They may be the remnants of a long-ago outburst from the central black hole, or evidence of intense star formation that once blazed through the core. Either way, these massive structures drift silently above the galaxy, invisible to human eyes. They are reminders that the Milky Way has a violent past we cannot fully see. Echoes of ancient outbursts wrapped in radiant energy far above the familiar stars. We live within a small spur between major spiral arms. Our solar system does not sit within one of the Milky Way's grand spiral arms. Instead, we reside in a smaller structure known as the Orion Spur, a quieter lane of stars nestled between the Sagittarius and Perseus arms. It is not especially crowded, nor unusually active, and that may be exactly why we are here. In this calmer zone between galactic highways, massive supernovae are rarer and extreme radiation storms less frequent. This peaceful corner may have allowed life on Earth the time it needed to emerge and evolve. From afar, the galaxy looks dramatic and radiant. But here, in this quiet spur, we found just enough stability for complexity to take root. The Milky Way has a bar-shaped center. When astronomers examine the galactic core using infrared light, they do not see a perfect circle. Instead, they observe a thick, elongated bar of stars crossing the center, like a glowing bridge. This bar rotates slowly, and its gravity helps shape the inner spiral arms. Bars like this are common in spiral galaxies. They form when stars in the disk drift inward and accumulate along a central axis. Over time, the bar stabilizes, stirring gas, triggering bursts of star birth, and feeding material toward the central black hole. It is not merely a shape, it is a dynamic engine, sculpting the galaxy's heart from within. The Milky Way is part of a larger family called the local group. Our galaxy does not drift through space alone. It belongs to a collection of more than 50 galaxies known as the local group, a modest cluster bound together by gravity. The two largest members are the Milky Way and Andromeda, each surrounded by its own system of satellite galaxies. Around them drift smaller dwarf galaxies, faint ellipticals, and dark matter-dominated systems. The local group spans more than 10 million light-years, and it is held together not by closeness alone, but by the invisible grip of gravity. We are part of this quiet family, widely spaced, yet bound by shared motion and mutual pull. The galaxies of the local group are gravitationally bound. Despite the immense distances between them, these galaxies are not drifting away forever. Many are slowly moving toward one another. Gravity holds them in a slow cosmic ballet, bending their paths over millions of years. Some of the smallest galaxies orbit the Milky Way like moons, looping and dissolving into faint stellar streams. Others wander independently, yet remain tethered within the group's shared web of motion. Over time, this gathering may grow tighter. Galaxies may merge, fade, or be absorbed. It is not a frozen arrangement, but a gentle convergence of cosmic islands. A family drawn closer by time, inertia, and the far-reaching pull of gravity. The galaxy's disk has both a thin and a thick layer. From a distance, the Milky Way's disk appears flat and smooth. Up close, however, it is layered. The thin disk is where we live, a dense, active plain filled with young stars, open clusters, and star-forming gas. Above and below it, lies the thick disk, older, puffier, and more diffuse. Stars in the thick disk tend to be ancient and poorer in heavy elements. Their orbits are more tilted and elongated, suggesting they formed under different conditions or were stirred by early galactic collisions. The disk of the galaxy is not uniform. It is textured and layered, shaped by time like sediment settling on the floor of a cosmic ocean. The galaxy's magnetic field threads through the disk. Though invisible to the eye, the Milky Way is woven with a vast magnetic field stretching across the disk, rising into the halo and winding through the interstellar medium. This field is weak by earthly standards, but across galactic distances, it shapes the paths of cosmic rays, influences how gas clouds collapse, and directs the flow of matter through space. It aligns with spiral arms, arches above the plane, and twists into loops that defy simple explanation. Studying it demands radio telescopes and precise observation. And yet, its reality is undeniable. The Milky Way does more than shine with light. It pulses with magnetism, a quiet rhythm flowing through its structure. The interstellar medium is filled with unseen architecture. Between the stars exists far more than empty space. This medium, a delicate mixture of gas, dust, and plasma, drifts through the galaxy like a ghostly mist. To human eyes, it remains mostly hidden. But through radio and infrared instruments, an intricate universe appears. Long filaments stretch across space. Expanding bubbles grow, shock waves ripple outward. Cold, dense clouds collapse into stellar nurseries. Supernova explosions hollow out enormous cavities. Stellar winds carve flowing patterns that travel for light years. The space between stars is no empty void, but a shifting network of matter and magnetic force. It is the silent framework from which galaxies transform, and life may eventually emerge. Cosmic rays move endlessly through us from across the galaxy. Each second, high-energy particles, mostly protons and atomic nuclei, pass right through your body, launched long ago from distant stellar explosions. These are cosmic rays, and they fill all of space. They race at nearly the speed of light, twisting through magnetic fields, deflecting off clouds of gas, and sometimes striking atoms in Earth's atmosphere, where they spark cascades of secondary particles. Most of the time, we sense nothing, yet they carry information from across the Milky Way. Evidence of ancient supernovae, traces of violent acceleration, echoes from the stormy hearts of stars. Even in stillness, the galaxy speaks through particles, through quiet, through unseen streams of lightless energy. The galaxy is not perfectly symmetrical, despite how it is often drawn as a clean spiral. The Milky Way is uneven in subtle ways. One side of its disk appears thicker than the other. Some spiral arms glow brighter, stretch farther, or curve more sharply. The outer disk is warped and tilted. Even the number of stars differs slightly from one galactic hemisphere to the other. These irregularities may come from gravitational encounters, past galactic mergers, or the influence of dark matter. They remind us that galaxies, like living beings, preserve their history in their form, bearing the scars of impact, the wrinkles of age, and the uneven growth that gives them depth and identity. The oldest known star may drift within our halo. Far above the galactic plane, moving quietly through the halo, astronomers have discovered a star that could be nearly as old as the universe itself. It contains almost no heavy elements, an unmistakable fingerprint of stars formed shortly after the Big Bang, before repeated supernovae enriched space with metals. It likely ignited over 13 billion years ago, long before the Milky Way reached its present form. Today, it glows softly in red, small in mass, but immense in history. It is more than a star. It is a cosmic time capsule, a living witness to the universe's earliest light. In the inner regions of the Milky Way, the center spins much faster than the outer edges. Stars near the core orbit at tremendous speed compared to those farther away. Close to the heart, gravity is intense, packed with mass from stars, dust, and the supermassive black hole known as Sagittarius A. Here, stars race along tight paths, finishing orbits in only a few million years. Farther out, in the quieter suburbs where our sun resides, stars move more slowly, taking hundreds of millions of years to complete a single journey. This uneven motion twists the galaxy, stretches its spiral arms, and prevents the disk from rotating like a solid object. The Milky Way turns like a vast wheel, but one whose rim cannot keep pace with its core. The spiral arms themselves are shaped by density waves. They are not permanent streams of the same stars locked in place. Instead, they are moving patterns, regions where matter becomes temporarily crowded as waves of higher density sweep through the galactic disk. As gas and dust pass through these waves, they compress, igniting bursts of star formation that illuminate the arms with brilliant young stars. Over time, those stars drift onward, and new ones take their place, sustaining the illusion of structure. Like ripples traveling across water or traffic bunching along a highway, the arms exist through motion. From afar, they seem still. From within, they are a flowing dance of gravity and time. Stars are born from cold, collapsing darkness. Within the shadowed arms of the Milky Way, star formation begins without sound. Enormous clouds of molecular hydrogen, sometimes spanning hundreds of light years, drift through space at temperatures only a few degrees above absolute zero. Inside these clouds, gravity slowly gains control. Pockets of gas become denser, pulling inward under their own weight. As material falls inward, it heats, spins, and flattens into a disk, forming a protostar at the center. With time, pressure and temperature rise until nuclear fusion finally ignites. A new star is born. From the coldest darkness emerge the brightest lights, shaped gently into existence by gravity alone. Star clusters do not always remain intact. Many stars are born together rather than alone, emerging in tight gatherings from the same collapsing cloud. Bound by gravity, these clusters drift as families for millions or even billions of years. But slowly, they begin to unravel. The Milky Way's tidal forces, close stellar encounters, and internal motion stretch the clusters apart. One by one, stars drift away until the cluster dissolves into the wider sea of the galaxy. Even our own sun was likely born this way, among siblings that are now scattered, faded, or lost across the vast distances of space. The galaxy also contains ancient hypermetal-poor stars. Among the rarest and most valuable stellar fossils in the Milky Way are stars whose atmospheres hold almost no elements heavier than helium. Some contain less than 100,000th the iron found in our sun. These objects are thought to be among the first stars formed after the earliest supernovae, carrying only the faintest imprint of a universe just beginning to enrich itself. They are unimaginably old, remarkably pure, and scattered through the halo like distant beacons from the dawn of time. Each one is a relic, glowing, bound by gravity, and carrying a nearly forgotten chapter of cosmic history. Planetary systems form everywhere, across the Milky Way. Planets are not rare exceptions. They are the natural outcome of star birth. As a new star ignites, a rotating disk of remaining gas and dust surrounds it. Within this disk, tiny particles collide, stick together, gain mass, and slowly grow into worlds. Across the galaxy, planetary systems are common. Some are giant systems of gas planets and frozen moons. Others are compact families of rocky worlds circling close to dim stars. Some may resemble our own system, while others challenge everything we expect. The galaxy is not merely filled with stars. It is filled with systems, solar families, each with its own balance, motion, and possibility. Earth lies near the co-rotation radius. In the Milky Way, the spiral arms rotate at a different speed than individual stars, behaving like moving patterns rather than solid structures. But there is a special distance from the galactic center, where the average orbital speed of stars matches the rotation speed of the spiral arms. This is known as the co-rotation radius, and our Sun orbits close to it. This gentle synchronization may help protect us from frequent crossings of spiral arms, regions packed with stars, supernovae, and gravitational disruption. We may live in a relatively stable neighborhood, sheltered not by barriers, but by orbital harmony. The Sun itself moves in a slow wave through the galactic plane. As it circles the Milky Way, it does not travel in a perfectly flat path. Instead, it gently rises and falls above and below the plane like a drifting cork, completing this vertical motion over tens of millions of years. This oscillation is driven by the galaxy's gravity, drawing the solar system back and forth along its path. Some scientists have even wondered whether this motion could influence long-term extinction cycles on Earth, though the evidence remains uncertain. Still, the message is clear. Even on its steady journey around the galactic center, the Sun is not gliding smoothly. It sways through space. We do not yet know what dark matter is, but we know it exists. Dark matter makes up most of the Milky Way's mass, yet it has never been observed directly. It does not produce light. It does not absorb it. It passes through normal matter as if nothing were there. And yet, its gravitational influence is unmistakable. It binds the galaxy together, explains the unexpected orbital speeds of stars, and shapes the formation of large-scale cosmic structures. Without dark matter, the Milky Way would tear itself apart. Astronomers detect it not by seeing it, but by watching how it moves everything else. It is the galaxy's hidden framework, silent, invisible, and still one of science's greatest mysteries. There is more mass beyond the disk than within it. Most visible stars of the Milky Way lie in the bright, flat disk we see in images. But the majority of the galaxy's true mass exists elsewhere. A vast dark matter halo surrounds the entire galaxy, reaching far beyond the furthest visible stars. This halo holds the Milky Way together and outweighs the disk by a huge margin. It contains scattered ancient stars in globular clusters, but its main substance remains unseen. When we imagine the Milky Way, we picture spiral arms filled with light. But that image is only the surface. The mass that defines the galaxy, its gravity, its motion, its reach, lies hidden in the dark, surrounding everything like a silent veil. The core of the Milky Way may once have blazed like a quasar. Today, the galactic center appears calm, but there are signs that it was once far more active. Enormous gamma-ray structures known as the Fermi bubbles, along with high-energy light reflected in nearby clouds, suggest that the supermassive black hole at the center may once have erupted as a quasar, a violent, brilliant beacon powered by falling matter. Quasars are among the brightest objects in the universe, capable of outshining entire galaxies. If our Milky Way once shone this way, it would have looked dramatically different. A spiral wrapped around a blinding core of light. That era has ended, but its echoes remain. The structure of the galaxy continues to change across billions of years. Galaxies may seem timeless, but they are always evolving. spiral arms shift. Central bars appear and fade. Gas streams inward and outward. Stars are born and die, steadily reshaping the stellar population. Even the Milky Way's disk, warped, rippled, and uneven, is slowly transforming. Encounters with dwarf galaxies and the influence of dark matter bend and twist its form. Across billions of years, the galaxy's outline has shifted like a drifting cloud. The Milky Way we see today is neither what it once was, nor what it will become. Its beauty is not found in permanence, but in silent transformation. Gravitational waves ripple through the galaxy, born from distant cosmic collisions. Throughout the universe, massive objects crash together. Black holes spiraling inward, neutron stars colliding, entire galaxies merging. These violent events send waves through the very fabric of space-time. Though incredibly faint, some of these ripples pass through the Milky Way, gently stretching and compressing space as they move. Detecting them is extremely difficult. Yet, observatories such as LIGO and Virgo have already captured several signals. New experiments now aim to detect the background hum of gravitational waves that fills the universe. Even as you rest, space itself is subtly shifting, not enough to feel, but enough to reveal that somewhere far away, the cosmos is changing. Not every star follows a neat circular path around the galactic center. Some travel along stretched, tilted orbits, long ellipses that carry them far above and below the disk, angled strangely from the main plane. These stars often come from different origins, remnants of dwarf galaxies consumed by the Milky Way or survivors of ancient gravitational upheavals. Their wandering paths serve as clues, three-dimensional maps of the galaxy's turbulent history. By tracking their motion, astronomers reconstruct the hidden structure of the Milky Way's mass and memory. These stars drift like messengers from shattered systems, twisted and displaced, yet still bound to the greater whole. The Milky Way releases neutrinos in staggering numbers every second. Trillions of these ghostly particles pass through your body each moment, arriving straight from the stars. They are created in nuclear reactions within the sun, in supernova explosions, and when cosmic rays strike atoms in space. The galaxy is flooded with them. Yet neutrinos interact so weakly with matter that they slip through almost everything, leaving barely a trace. Only specialized observatories deep beneath Earth's surface or buried in polar ice can occasionally catch one. Seen as a rare flash of light, neutrinos carry information from places beyond our view. From stellar cores, collapsing giants, and the hidden energy of the galaxy. They are the murmurs of cosmic fire. Interstellar space is not empty. It is restless and alive. Between the stars, the interstellar medium of thin gas and dust clouds is stirred by shock waves, magnetic forces, and stellar motion. Temperatures swing wildly. Streams of matter collide, blend, and fragment. Clouds stretch, twist, and tumble. On vast scales, this motion creates turbulence, a slow-moving ocean flowing through the galactic disk. Star birth, cosmic rays, and even the long-term evolution of the galaxy are shaped by this restless motion. What appears from afar as calm starlight is, up close, a rippling, energetic fabric molded by hidden winds and ancient power. The galactic halo may be home to wandering planets. Not all planets remain tied to stars. Some form in normal systems and are later flung outward. Others may have formed alone, without any star at all. These are rogue planets, cold, dark worlds drifting freely through the galaxy. Though difficult to detect, studies suggest billions may exist within the Milky Way, even in the distant halo where starlight is scarce. With no warmth or illumination, they travel unseen. warmed only by faint internal heat. They are orphans of the galaxy, planetary travelers moving along lonely paths through interstellar darkness. Magnetic fields guide the movement of cosmic dust. Interstellar dust, tiny grains of carbon and silicate, does not move solely under gravity. It is also shaped by the galaxy's magnetic field, which threads through the Milky Way like invisible currents. These fields steer charged particles and influence how gas and dust align. In some places, dust grains spin rapidly, releasing faint microwave radiation. In others, they align with magnetic lines, polarizing the starlight that passes through. By studying these effects, astronomers trace the structure of galactic magnetism and even remove its interference from cosmic background observations. Dust is not passive. It moves to a magnetic rhythm, sketching hidden patterns in the dark. Some stars bear the chemical mark of neutron-star collisions. When two neutron stars spiral together and merge, they produce one of the universe's most violent events, a kilonova. In this brief but blinding explosion, vast quantities of heavy elements are forged: gold, platinum, uranium, and more. These materials are hurled into space, mixing with surrounding gas and eventually becoming part of new stars. Certain stars in the Milky Way carry the chemical fingerprints of these rare collisions, enriched with elements that could only have formed in such cataclysms. They are not merely glowing orbs, but record keepers of ancient violence, shining with a residue of stellar wreckage and cosmic alchemy. The Milky Way may hide a bar within a bar. At the galaxy's center lies a broad bar of stars, an elongated bridge of light crossing the central bulge. But embedded within it, astronomers have found signs of a second, smaller bar, tilted at a different angle and rotating independently. This inner structure is difficult to observe directly, obscured by dust and distance. Yet its gravitational influence appears in the motion of nearby stars and gas. Such bars may help funnel matter toward the supermassive black hole, feeding it and shaping the core's behavior. The galactic center is not a simple form. It is a layered, shifting maze of motion and light. Gas flows inward to feed the galaxy from the cosmic web. The Milky Way is not a closed system. It draws fresh material from the intergalactic medium along vast, delicate threads of matter. These inflows provide the raw fuel for new stars, replacing what the galaxy consumes over time. Some gas arrives as cold, narrow filaments slipping quietly into the disk. Other streams plunge in hot and shock-heated, glowing in ultraviolet or X-ray light. These unseen rivers sustain the galaxy's growth and connect it to the larger universe beyond. Even now, the Milky Way drinks from distant reservoirs, nourished by matter spun from the early cosmos. Hot gas bubbles carve chimneys through the galactic disk. When clusters of massive stars explode as supernovae, they create enormous cavities in the interstellar medium. These cavities can merge into superbubbles, vast pockets of superheated gas that punch upward through the disk and vent into the halo. The result is a network of chimneys, channels through which energy, gas, and magnetic fields escape from the plane of the galaxy. These structures regulate pressure, redistribute heavy elements, and help shape the halo itself. In this way, the galaxy breathes not only within the disk, but through towering columns that carry its energy upward into the dark. The galaxy shines fiercely in X-rays. Though the Milky Way appears calm in visible light, it burns brightly in other wavelengths. X-rays stream from its core, from collapsed stars, and from the surroundings of black holes. White dwarfs and neutron stars in binary systems can siphon matter from companions, heating it to millions of degrees. Hot gas in the halo also emits faint X-rays, outlining the galaxy's larger skeleton. Our eyes cannot see this high-energy light. But observatories like Chandra and XMM Newton reveal an entirely different galaxy. Not a peaceful spiral, but a realm of extreme heat, compact remnants, and hidden radiation. Pulsars serve as cosmic clocks across the Milky Way. When a massive star dies and collapses into a neutron star, it may be left spinning rapidly, with beams of radiation sweeping through space. These are pulsars. Some rotate hundreds of times per second, flashing with astonishing precision. Their rhythms are so reliable that astronomers use them as cosmic timekeepers to measure distances, test gravity, and even search for gravitational waves. Across the galaxy, pulsars blink steadily, remnants of stellar death, yet beacons of incredible order. They mark time not in seconds or years, but across the vast stretches of cosmic history. Radio waves reveal the galaxy's hidden structure. Much of the Milky Way is invisible in ordinary light, obscured by dust, distance, or faintness. But radio waves pass through these barriers, exposing what light cannot. They trace cold hydrogen gas, outline magnetic fields, and highlight emissions from pulsars, supernova remnants, and even distant quasars beyond the galaxy. Using networks of radio telescopes, astronomers have mapped spiral arms, measured the disk's warp, and uncovered star-forming regions buried in darkness. Where light fails, radio signals reveal form. The galaxy speaks in a silent language that science has learned to interpret. The Sun was almost certainly born in a stellar cluster. Stars rarely form alone. They arise in groups, clusters forged from the same collapsing cloud of gas and dust. Our Sun was likely one of these. Long ago, it shared its birthplace with hundreds or thousands of sibling stars. Over time, gravitational tides, passing stars, and the motion of the galaxy scattered the cluster. Most of the Sun's siblings drifted away, cast into different orbits, carrying fragments of a shared origin. Some may still lie nearby, hidden among the countless stars, lost family in a vast ocean of light. The Sun's siblings are scattered across the galaxy. Though its birth cluster dissolved long ago, astronomers continue searching for its long-lost relatives. Stars that share the same age, motion, and chemical signature. Using immense surveys like Gaia and spectroscopic databases, researchers hope to identify these stellar kin. A few candidates have already appeared. If confirmed, they could reveal the conditions in which the Sun and the early solar system formed. Our place in the galaxy is not entirely solitary. Somewhere in the depths of space, the Sun's ancient family may still shine. The galactic disk wobbles as it turns. The Milky Way's disk is not perfectly flat. It gently ripples, like a spinning plate nudged out of balance. This warp is most noticeable in the outer regions, where one side of the disk bends upward while the other dips downward. The distortion may be caused by interactions with nearby dwarf galaxies, clumps of dark matter, or internal imbalances. The wobble itself rotates slowly, like a vast wave flowing through the stars. From Earth, we feel nothing. But from afar, the Milky Way is not a flawless spiral. It is a breathing, undulating sheet of stars. Galactic tides can stretch and tear stellar systems. Just as the Moon raises tides on Earth, the immense gravity of the Milky Way pulls unevenly on everything within it. Star clusters, satellite galaxies, and globular groups all feel this tidal force. Over time, it can stretch and distort them, pulling out long streams of stars or stripping members from their orbits. Many faint stellar arcs mapped across the sky are relics of these encounters, clusters in the process of being unraveled, galaxies slowly pulled apart. The galaxy rarely destroys suddenly. It dismantles patiently, thread by thread, across millions of years. The true mass of the Milky Way remains uncertain. One might assume we know the weight of our own galaxy, yet measuring it is surprisingly difficult. Ordinary stars and gas account for only a small fraction of the total. The rest lies hidden in the enormous halo of dark matter, unseen and elusive. Estimates vary widely. Some place the total mass near 1 trillion times that of the Sun. Others suggest far more. The challenge comes from trying to track the motion of stars at extreme distances, where limited data and invisible matter cloud the results. The Milky Way is our home, but its true weight remains a quiet mystery. It may even outweigh Andromeda. For many years, astronomers believed the Andromeda Galaxy, which appears larger and brighter, must also be more massive. But recent studies suggest the Milky Way's dark matter halo may be broader and denser than once thought. If so, our galaxy could be the heavier of the two despite its modest appearance. This matters not just for comparison, but for the future. When the two galaxies finally merge, their relative masses will shape the nature of the collision. The Milky Way may look gentle, but beneath its calm spiral arms, it carries more weight than once imagined. The Magellanic Clouds may be newcomers. The Large and Small Magellanic Clouds, two bright satellite galaxies visible from the southern sky, were long believed to be longtime companions of the Milky Way. But new evidence suggests that they may be recent arrivals, captured only in the latest chapter of cosmic time. Their speed and motion hint that this could be their first close passage. If true, they are not ancient partners, but wandering visitors now falling into the Milky Way's grasp. Their arrival has disturbed the outer disk and warped the galaxy's shape, as if our galaxy is reacting to a newfound gravitational guest. The Magellanic Stream is a ribbon of stripped gas. Trailing behind the Magellanic Clouds is a vast river of hydrogen gas known as the Magellanic Stream. It stretches for hundreds of thousands of light years across the southern sky in long arcs and curves. This gas was pulled away by tidal forces as the dwarf galaxies passed near one another and near the Milky Way. Invisible to the eye, it reveals itself in radio wavelengths, a lingering trail of loss and motion. One day, this stream may help fuel new star formation in the Milky Way, or settle into the halo like a thread of memory connecting galaxies. Some gas clouds follow polar orbits. Not everything in the Milky Way circles neatly within the disk. Some clouds of gas, and even some stars, travel on highly tilted paths that take them above and below the galaxy's main plane. These polar orbits likely originate from past mergers, when dwarf galaxies or wandering clouds were captured at odd angles. Even after settling in, they continue to move on slanted paths, like comets around a planet. These misaligned motions are scars of disruption, visible reminders that the galaxy is an evolving system shaped by unpredictable encounters. Giant shells of gas mark ancient starbursts. In several regions of the Milky Way, astronomers have discovered enormous spherical shells of gas, some spanning hundreds of light years. These shells are the leftovers of powerful starbursts, times when clusters of massive stars formed together, lived briefly, and then exploded in rapid succession. Their combined winds and supernovae carved immense cavities in the interstellar medium, blasting gas outward in all directions. Over time, the expansion slows, but the shells remain, ghostly bubbles marking where the galaxy once burned with intense stellar life. They are fossils of cosmic fireworks, still echoing through the cold. Stars can collide in the densest stellar neighborhoods. Space is vast, and stars are small. Yet, in the tightly packed cores of globular clusters, stars can pass close enough to interact, and sometimes even collide. When they do, the results can be dramatic, flashes of light, merged stars, or the creation of rare blue stragglers that appear younger than those around them. These collisions are uncommon, but over billions of years, even rare events become possible. In the galaxy's crowded stellar cities, gravity and chance slowly reshape the population. Binary stars can be torn apart by gravity. Many stars exist in pairs, locked in mutual orbit. Yet even this bond is not unbreakable. If a binary system passes too close to the central black hole or through a dense cluster, tidal forces can disrupt the pair. One star may be flung outward, while the other is captured or slowed. In some cases, a star is hurled completely out of the galaxy, becoming a rogue object racing through intergalactic space. These quiet breakups happen far from our sight. Ancient partnerships undone by gravity's relentless pull. Some stars escape the Milky Way entirely. Though most stars remain bound to the galaxy, a few achieve escape velocity, over 500 kilometers per second, and are flung outward forever. These hypervelocity stars are rare, but real. Some are launched by close encounters with a supermassive black hole at the galactic center. Others are hurled outward by supernova explosions or complex three-body interactions. Once free, they travel alone through the void between galaxies, tiny lighthouses drifting beyond the spiral's edge, carrying the Milky Way's story into the deep. Some stars within the Milky Way were born elsewhere. Not every star now inside our galaxy formed here. Some originated in other galaxies and were captured during mergers or flung into our halo from distant regions of the local group. These intergalactic wanderers often follow unusual paths far from the disk. Their compositions and motions reveal that they do not quite belong to the local pattern. Like cosmic immigrants, they carry the memory of other skies and other homes. The Milky Way is not sealed. It is a living mosaic assembled over time. The galaxy cycles gas between disk and halo. Above and below the bright disk, gas rises and falls in a slow loop known as the galactic fountain. Supernovae and stellar winds heat material and drive it upward into the halo. There, it cools, condenses, and gently settles back down over millions of years. This cycle stirs the interstellar medium, spreads heavy elements, and helps regulate the pace of star formation. It is a quiet breathing of matter between the dense disk and the vast halo. In this way, the galaxy does more than spin. It circulates. The galaxy's dust carries organic chemistry. Within the drifting clouds of interstellar dust, scientists have detected complex carbon-based molecules, the building blocks of life. These include polycyclic aromatic hydrocarbons, simple sugars, alcohols, and more. Though not alive, these compounds are chemically rich. They form in dying stars or within cold clouds shaped by radiation. Carried across light years by galactic winds, these grains settle into the gas that forms new stars and planets. Some may have fallen onto the early Earth. The galaxy's dust is not merely debris, it is a cargo of possibility. Interstellar clouds may seed solar systems with life's ingredients. The birthplaces of stars are also the birthplaces of worlds. As planetary systems form from collapsing clouds of gas and dust, they inherit the chemistry of their parent nebula. If that cloud contains water, carbon compounds, and other biological ingredients, those materials may become part of comets, asteroids, and planets. Some regions of the Milky Way are especially rich in such prebiotic chemistry. We do not yet know how common life is, but the conditions for it seem to arise naturally across the galaxy. Some stars spin hundreds of times faster than the sun. Most stars rotate, but some spin at astonishing speeds, completing a full turn in only a few hours. These rapid rotators are often young and massive, with equators that bulge under centrifugal force, Some spin so fast that they fling off material, forming glowing disks around themselves. By comparison, the sun rotates once every 25 to 35 days. These extreme stars live differently, evolve differently, and burn through their lives quickly, spinning like sirens in the dark. The Milky Way is tilted relative to the ecliptic. From Earth, the galaxy arcs across the sky as a luminous band, but it does not align with the plane of our solar system. The galactic plane is tilted about 60 degrees relative to the ecliptic, the path traced by the sun and planets. This tilt explains why the Milky Way rises at an angle and changes position with the seasons. We belong to the galaxy, yet our small system travels at a slight tilt, like a narrow boat drifting across a vast, rotating sea. Some stellar remnants are older than the galactic disk. Among the faint stars of the halo, astronomers have found ancient white dwarfs, the cooling cores of long-dead stars, older than the Milky Way's main disk itself. These remnants formed in the galaxy's early era, before its structure had fully settled. Their existence points to an even deeper history hidden in the halo. For billions of years, they have faded quietly, carrying the residue of a time when the Milky Way was still gathering its shape. The most distant stars orbit far beyond the main structure. The Milky Way's farthest stars travel tens or even hundreds of thousands of light years from the center, deep within the halo. Their orbits are slow and wide, taking billions of years to complete a single cycle. Many were likely captured from smaller galaxies long ago. They drift like distant sentinels at the galaxy's edge, faint and scattered. Though few in number, they define the true size and gravitational reach of the Milky Way. The Milky Way's shape is subtly lopsided. Though often drawn as a symmetrical spiral, the galaxy is uneven in several ways. One side of the disk is thicker. The spiral arms differ in brightness and length. Even the halo is slightly off-center. These imbalances likely result from interactions with the Magellanic Clouds, clumps of dark matter, and ancient gravitational disturbances. The galaxy's shape has been influenced by past mergers and distant gravitational encounters. It is not a flawless pinwheel. Instead, it is a living structure shaped by pulls and distortions, like a spinning dancer whose flowing skirt is tugged by unseen winds. Its beauty comes from this unevenness, a graceful imbalance carved slowly by time. Astronomers chart the galaxy using variable stars. Some stars rhythmically brighten and fade, swelling and shrinking like slow, glowing heartbeats. These are known as variable stars, and certain types, such as Cepheids and RR Lyrae, follow a reliable relationship between how bright they shine and how fast they pulse. By measuring their cycles, astronomers determine their true brightness, and by comparing that to how bright they appear, they can calculate distance. These stars become cosmic measuring tools, helping map the Milky Way's size, shape, and structure. They are steady beacons flashing through the dark, marking the spiral from within. The Gaia mission is transforming how we understand our galaxy. Launched by the European Space Agency, the Gaia spacecraft is assembling the most precise map of the Milky Way ever created. By tracking the positions, motions, and brightness of more than 2 billion stars, Gaia reveals the galaxy in 3 dimensions and shows how it changes over time. It has uncovered streams left behind by shattered galaxies, charted the bending of the disk, and traced the sun's long journey with remarkable accuracy. With every new release of data, Gaia sharpens our picture, turning a blurred glow into a living, moving portrait. It is one of astronomy's greatest achievements, an ongoing revolution written in starlight. The galactic plane appears as a dense path of stars across the sky on a dark, moonless night far from city lights. you may notice a faint river of glowing mist overhead. This is the galactic plane, the thickest cross-section of the Milky Way's disk. It is not a thin line, but a vast, flattened band packed with stars. Here, dust layers are thick and star formation is active. From our position, we are looking along the grain of the galaxy, peering through its most crowded corridors. This band is not just visually stunning. It marks the bustling heartland where most stars are born and where many will eventually die. The night sky grows brighter toward the galactic center. The core of the Milky Way lies in the direction of the constellation Sagittarius, a dense glowing region filled with stars, dust, and hidden mass. From Earth, we cannot directly see the center in visible light because thick clouds of dust block our view. Yet, in infrared and radio wavelengths, the region shines intensely. Even with the naked eye, this area appears richer and more crowded with overlapping starlight. We orbit far from this brilliant center in a quiet outer neighborhood of the disk. But when we gaze inward, we glimpse the crowded metropolis at the galaxy's core. We observe the Milky Way edge-on from Earth. Because we reside inside the galaxy, we cannot look down on it from above. Instead, we see it as a flattened ribbon of stars stretching across the sky, gently curved only by the horizon. This inside view compresses the galaxy into a single glowing arc, making its true spiral form difficult to grasp. It took centuries of careful observation, mapping, and mathematical insight for humanity to realize the vast spiral structure we inhabit. From Earth, it is like standing deep in a forest and looking straight through the trees. We sense the immensity, but not the full shape. The galaxy contains far more than we will ever directly see. Even with our most advanced instruments, we observe only a fraction of what exists. Dust blocks light. Motion hides in silence. Dark matter outweighs the stars we can see. Between every star lies emptiness, and within every emptiness, potential. The Milky Way is not only what appears before our eyes, it is also what we deduce, what we imagine, and what we seek to understand. It holds ancient light, unborn stars, wandering worlds, and mysteries still unanswered. And within that immensity, somehow, we exist. One small world among countless others, orbiting a quiet star, drifting through a story far larger than sight alone. Now the stars begin to fade behind your thoughts. We have moved through countless quiet truths, from the bending of the galactic disk to the farthest halo stars, from newborn suns to long-dead remnants, from dust and gas to light and shadow and everything in between. You have drifted through stellar nurseries, traced the curves of spiral arms, and looked toward the glowing heart of the galaxy, hidden behind veils of dust. You are part of all of this. Not merely a passenger on Earth, but a participant in its long and radiant evolution. The iron in your blood was forged in stars. The oxygen you breathe was shaped in ancient explosions. Every atom in your body carries a history that reaches back to the beginnings of time, born from the same matter that now fuels stars and whispers through the clouds between them. Tonight, as you rest, the galaxy continues its motion. Stars are being born, light is traveling, silent orbits carry on, and you are floating within it, a small warmth in the vast dark, resting in a spiral arm of a quiet, shining sea. If you are still awake, you may continue into the next chapter now. Until then, sleep gently and dream softly. Good night.